12. Waiting for verification that I'm actually streaming. Oh, there we go. I'm going to do some AV check. 1, 2, 3, 4, 5. All right, it seems to be working, and you can even hear my son who had the flu coughing in the background. So interesting. My noise filter usually filters that stuff out, but I guess that cough was loud enough. Hey there, Syrian. This is an EU-friendly timed stream because it's the weekend. I'm going to be doing Advent Code Day 12, so that unlocked, what, 16 hours ago? So I'm 16 hours behind, but that's okay. While the stream is starting up, I'll just start by setting up a place for me to put the Day 12 code. This sort of works out, right? It's like people aren't instantly here because my stream schedule is sort of erratic, and so like while people are filtering in, getting the notification I'm streaming, I'm setting up by like doing the boring stuff first, setting up all the boilerplate stuff, and then when people are actually here, then we can actually do the puzzle. I think that's a good plan. Hi, Endorn. How are you doing? You're gonna get spoilers if you watch me. I hope that's okay, unless you've already done Day 12. Just to let you know, if you haven't done Day 12, it's gonna be spoilers. You're at Day 8. So maybe by the time you get to Day 12, you won't remember my solution. Part 2 of this one didn't go where you thought it would. Uh-oh. Uh-oh. Hey there, Romania Hate. Transhistoric IO, hello. It's 10 p.m. here, so slightly preparing for bed. So, but it's sort of EU friendly, I hope. It's not as EU unfriendly as I normally am, like 4 in the morning or something. This is this early? It's sort of EU friendly, so I should have started a little bit earlier. So what the optimal time would be what? 2 hours ago, maybe? Prime time? 2021 cargo run 12-1. Nick sounds weird outside of Polish. It's probably just because I said it wrong. The puzzle unlocks at 6 a.m. for you. Yeah, I mean, 6 a.m. on a weekend is really unfriendly, right? And it's not so bad on the weekday because you might be getting up, getting ready for work or something, but still not the best. Okay, let's start Day 12. Let's see. I hope it's a good one. So Advent Code standard quick intro with the links. And I misspelled that. Let's get all these misspellings out of the way right now. It's an advent calendar of programming puzzles. So from December 1st to 25th, you get 2 little puzzles that are related to each other. And you can solve them in any programming language you want. The website just asks for you to type in a number as an answer. And but it's usually something where to get that number, you have to run a program. It's not something you can do with pen and paper or in your head. And they're Christmas themed. They're usually pretty corny. So the theme this year is that we've dropped the keys to Santa's sleigh in the ocean, and now we're in a submarine trying to find them. So various adventures. Let's see what we have in store for us today. So do you know a Rust master? Musen or Jinho or who was it? I can't remember the name. I would say that those are Rust masters. Oh, Sarian's a Rust master, of course, right? Passage pathing. With your submarine subterranean subsystems subsisting suboptimally, the only way you're getting out of this cave anytime soon is by finding a path yourself, not just a path. The only way to know if you found the best path is to find all of them. I think Sarian is better than me. TS Just, how are you doing? If you're looking for a master at solving Advent Code puzzles, here we have TS Just himself. Yeah, well, this is a little bit EU more friendly. So you can listen to my voice and it'll put you to sleep, TS Just. That's the whole point, right? Fortunately, the sensors are still mostly working, and so you build a rough map of the remaining caves. For example, start A, start B. Is that the actual example we're going to be using? Probably not. You guys have to get up early on Monday. I'm sorry to hear that. I usually go to bed at midnight. Okay, this is a list of how all of the caves are connected. You start in the cave named Start, and your destination is in a cave called End. The entry like B. Oh, this is like a path. What is it called? I forget the name of this. But we're gonna draw like a directed graph, right? And we're trying to it's something spanning. Path spanning? Spanning tree? Someone in the background? Yeah, I got my family all around me. So my son is behind me playing something. Having a party? I don't know what game he's playing, but I'm sure he's having fun. Risk of Rain, he says. So Risk of Rain 1 or 2? 2. Risk of Rain 2. Oh, hey, I played that game. Okay, anyway. An entry like BD means that KB is connected to KD. You can move between them. So in the above case system looks roughly like this. So we can go start A to end or start B to end, but D, C and D are dead ends. Okay. Your goal is to find the number of distinct paths from start, end at end, and don't visit small caves more than once. There are two types of caves. Big caves written in uppercase like capital A, and small caves written in lowercase like B. It would be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. So all paths that you find should visit small caves at most once, and you can visit big caves any number of times. Given these rules, there are 10 paths through this example cave system. Start capital A. Oh, I forgot you can go between A and B. Then to B, then to A, then to C, then to A, then to end. Okay, I got it. Each line in the above list corresponds to a single path. The caves visited by the path are listed in the order which the visit is separated by commas. Okay. Note that in this case system, D is never visited by any path. To do so, B would have to be visited twice. Got it. Here's a slightly larger example. The 19 paths through it are as follows. Finally, this even larger example has 226 paths through it. Okay, so they were generous. They gave us 3 different sets of rules. So let's have 3 unit tests. Day 12. Oh, I forgot to clean this up. I should have done that before I started. Clean up parts 1 and 2 so that they're empty. Okay, so we have test part 1. Actually, no, I can just make it all part of the same, right? Here's the example, one of the examples. And the answer to that was 10, right? All right, and copy that 2 more times. So here's the second example, slightly larger. Okay, and that's 19. And an even larger one here, which has 226. All right. Make sure that can run. It can't because I'm missing the input. I must have deleted it by accident. Yeah, I did. Let's put it back. 12. We don't have a day 12 input. Let's make an empty one. Actually, let's go ahead and get our input now. Here's our input. There we go. All right. Beep, beep, beep. Microwave active. Oh, you heard the microwave beeps? Oh, it's lunchtime here, right? It's like 1:18 in the afternoon, or 13:18 military time. So we're going to get these fail because not implemented. Just checking. So let me think how we would solve this. They all caps? They are all caps. So, alright. We have we have 4 different kinds of rooms. So I feel like I should identify them. Enum room. So we have the start room, the end room, and then we have the big room. Keep them in capital. Keep them in order by alphabetical. Big, and then we have a string, and small. Right. So let's first put them, parse them. So we're gonna reuse this between part 1 and part 2 anyway. So let's just make a function called parse input. So the input is that, and we're gonna get back. I think I'd just keep it as a hash set of room. Hash set import. Yeah. What does it not like about that? Probably because we haven't implemented it yet. Input.lines .map line trim. And then oh, we're gonna see the same thing twice. So it's actually not rooms, it's like rooms and connections. So can I get back both the rooms and the connections? Connections, that could just be a vector, right? With just copy it. These can all be shared, actually. There's no reason to have these yeah, we can borrow them. That way they're copyable, right? So I'm gonna need to make my hash set early. Hash set new. And then I guess we'll just have the connections. Line trim, and then I feel like I should just make another like a from string. Implement from string for room. Type error. Do I need an error? No error type. There are no errors. So then I can just say into there. And then we're going to return rooms connections. That's not right. I didn't do this right. Shoot. Not into. Split once on the dash, and then let from to equal that. And then it'll be this is going to be collect from into to into. Mismatch types. Oh, unwrap that. Hold on, I missed a whole bunch of stuff. EU is going to bed. Ryan would start stream. EU is going to bed late. They should go to bed late. So basically, we have to count how many paths lead to the end. Yeah, with some special rules where we don't visit the small rooms more than once. And we always start at start and we end at end. We can visit the big room any number of times. Those are the rules. You like to use the scan format crate for these types of parsers? Yeah, I'm trying to do it without too many crates. Just doing it with vanilla Rust. Split once operator, use the from to. Yeah. Yeah, whenever you're going to split and you're going to have two things, split once is a useful shortcut rather than doing a split and then having to take two and then unwrap that. I think it's really just, if we look at it, it just internally does that. It does next. And what is this? Okay, maybe it's specialized. I thought it was going to just do split and then take two, but I guess oh, wait a minute. No, it can't do take two. Yeah, it actually finds the delimiter and then takes the left and right. Yeah. Because there could be more dashes and they end up on the right. Okay, why isn't my into... Oh, is it into string? I forget how to use from string. Is it to string? From string. Let me look up. I don't use from string a whole lot, so let me look it up. So let's see. It's just from string. Okay, so it's do we have to say room from string? That's too bad. I was hoping I could abbreviate and not say room twice. Okay, what does it not like about collect? Oh, those are results. Unwrap. There we go. So we need to implement from string. Okay, so 2 rooms. I have to be careful because 2 rooms could be the same but have 2 different addresses for the name. I think the comparison for string slice, it's equal if the contents are equal, not if the references are equal, right? Or do I need to dereference them? Anyway, I might have to be careful about that. I guess I could just turn them into capital string owned, and then the comparison for that definitely is looking at the content. Anyway, I'm just musing about, do I need to worry about the comparator? Well, we'll have to implement that anyway. Let's hope that the derive for partial equal that we'll need later works for that. Anyway, should I hold off on that before and wait until I need it? To use Rust at work too, a little bit. Thank you, Rocklebest. I mostly just use Rust for like making little one-off tools, but I don't use it enough, so that's why I do contests like this to get some excuse to program in Rust some more, so I don't get rusty on my Rust. You don't use iter tools either? No, I don't use iter tools. Oh, does parse? Should I just be using parse? Oh, thank you, SilentZ. Yeah, so then this would be from.parse.unwrap. That's much better. Thank you. That deserves a point. That deserves 3 points, I think. All right, so while I'm getting these rooms though, so like let's actually take these out and let 2 equal that, I want to insert them into the rooms. So rooms, this needs to be mutable, because we're going to say rooms.insert from, which to make that work I need to make them copy types, which we can do. We just derive clone and copy. That's not enough? Oh, they have to be hashable and equatable. Equal, hash, partial, equal. Sure, all that good stuff. And collect didn't work because I didn't actually do a from to. Okay. So that makes sure that every rooms we see end up in the rooms hash set that gets returned. Because I'm just thinking I'm going to need that hash set later. Maybe I don't. But let's say let rooms connections equal parse input. What to do now? Back to the problem. Okay, so I might want to actually have a different container other than a vector of tuples. I actually might want to form a map from room to other room. Well, a room from room to a set of other rooms. Because like at start I want to quickly get to both start A, start B, right? I think in general, what I can do is just do a lazy approach of doing a recursive call, but accumulate the set of small rooms that we've already visited, and just don't follow paths that lead to that go through those if we've already visited it. And the call will ultimately return none if there's like no way to get to the end, right? Hey there, Owen Coates. How are you doing? As usual, you just fade into obscurity. What are you talking about, Frosty? Oh, I didn't see your message 4 minutes ago. Wow, there's a face I haven't seen in quite a while. How are you guys doing? Doing pretty well. You know me, I don't always see all chat messages. I'm sorry about that. Get up at 6 a.m. in the EU here. Yeah, I can never pick an EU-friendly time. When I try, it's always too late in the evening or too early in the morning. Watching Irish John's game stream much these days, think he's nearly finished? Yeah, he was going into early access on Steam, right? I don't watch Twitch as much because I have a full-time job now. But when I do watch, I just lurk different channels, and I usually lurk programming channels. I haven't seen Irish John as much though. Okay, anyway, I think I do want to change this type of the connections to a, which means I might not need this hash set room. Which means I can combine these two together actually. Yeah, I'm gonna do that. I'm gonna make this a hash map. Whoa, how'd that happen? Hash map from room to vectors of rooms. No, hash sets of rooms. That's what I want to do. Which means I still need this hash map. This is not a tuple anymore. Hash map needs to be imported. When we get these rooms, I want to say rooms. This isn't rooms anymore, really. This is no, that is rooms. There's one for each room. Rooms.entry from or default dot insert what does or default return here? Yeah, mutable reference to the value, which in this case is a hash set. Insert the 2. And then I actually don't need to collect it at all, so I can just, there's no connections. It's just for line in that. Get rid of the map. there, and it's just rooms. So let rooms equal that. Is there no default for my hash map? Annotations needed. Okay. I thought or default. Oh, do I not have a default implementation? Do I need a default implementation? Oh no, the default is on the hash set. It knows the type of rooms, so what's wrong with this? Type must be known at that point. Consider giving rooms explicit type. Okay. I mean, I can do that. I can do it with a turbofish, actually. Turbofish! Oh, is it because this whole line is wrong? Right. Semicolon. So then maybe I didn't need the turbofish.
Wait, there's literally another.
No, still need the turbofish. Turbofish stays. Okay, anyway. Let's do this one. This is an easy one, right? It will be match s start, right? Is self start. I don't know. Should I use self or should I use room? I kind of feel like I should use room, but another part of me wants to use self just in case I change the name, but it's easy to change names later. I don't know. Let's use room.
Well, you know what?
And this whole thing needs to be put into an okay, because it's always going to be okay. It didn't cover, that's correct, because if it's anything else, then it is going to be a panic. Actually, I don't know if I even need that. Let's do end, room, end. So how do we capture if it's capitalized? So it would be something like in, or name if. Is there an all caps capitalized? I guess I can just make a function all caps boolean, and we can say like a find input.chars find c is upper is lowercase, sure. It returns an option, so I need to turn an option into a bool is some. I guess that's the equivalent of any, right? And it would be not that. If all caps room big name, and then name if not all caps. That should be no, that's not exhaustive. You can have a mix, right? And then oh, this isn't right then. This should be all, not, and I should have let's call this all upper and all lower, where it is lowercase or it's not lowercase. So this is all upper and if all lower. Now it's obviously not exclusive. Like these don't cover everything, so I have to have a mix. In which case we're gonna panic. Bad input. It should be exhaustive. Oh, wait a second. Can I infer types? Do I need to say that it is plus A or something? I guess do I have to say like A? Or implicit? I forget how to do this. Is it plus implicit. No, that's not right. I have to figure this out before I record the next Rust video I do, by the way. This char is ASCII uppercase. Oh, so I don't have to do the not lowercase? And Sarian said that too. This trait can't be implemented with lifetimes. Really? Why not?
I just shield swap best.
So I can't even use the from string trait at all? So I had to make my own thing? I mean, I could just make it. I can just say implement that, and then I don't have an error. That actually might be simpler. I just can't use parse now. I can call it parse, and it just returns self. Of A. Can't do that because they're not allowed in that position. What's the deal here? Oh, there's a result. I don't need a result. Explicit lifetime required in the type of SA is required. Yes, that is true. There we go. And then I have to use the other form, room parse. From. There we go. Room parse 2. You can try into. That's okay. This is cleaner anyway. It's just our own small implementation. So this tells me I forgot to use small here. There we go. I did it. All right, now rooms are all parsed. We got into a nice hash map. So time to solve it, I guess. So let start equal rooms dot get. Oh, we can just index it, right? Rooms start. I thought I could index a map that way. Oh, I have to borrow the start. And why is that an error? Cannot move out. Sure, just borrow the room. And then I think we'll call we need to have some state about visited. Visited equal hash set new, and then we'll just say find paths, because I need a recursive function. Find paths. I can't just take the start. I need to make it like I need to tell it what the current room is and the rooms we visited. So that would be we'll just have the logic not. I don't even have to. We'll just have an empty set. So yeah, I don't even need this to be mutable, right? It'll just be copied before we can make the recursive call. That's where we're gonna. Now I know why Sarian was saying in Discord he had a lot of copies, a lot of memory allocations. Because if you do this recursively, you're going to end up copying the visited set every time you branch off, right? Find paths from the room start to... Actually, it's start. Or I can have it just look it up. How do I want to do this? I think I want to do it with the actual room borrowed. To string. And we'll call it count paths. Alright, so count paths takes, well, it's generic on some lifetime. it's going to take an initial room. So, well, current room, a lifetime of a room, and then I need the rooms too.
Try to hit one foot, dude.
Borrow that rooms. So rooms.
Hit one.
Yeah, all the same lifetime just to make it easy. This guy. We'll call this current. And then visited. Is a hash set of room. A. Lots of lifetimes. I don't know if I need all these, but it's returning a counter. To do. Make sure I got all the types right. Okay, mess something up. Oh, in parentheses. There we go. Probably because it's mismatched. Oh, did I have this wrong? Yeah, this should be visited. Well, hold on. I guess it can be owned. Right? And it'll just end up internally copying it and passing the copy recursively. So I don't need this. All right. So far, so good. The mute should probably have a different lifetime than the element. It doesn't matter to me. All the same lifetime. The borrow first hash map and the T hash set are the only ones that need a share lifetime. You're borrowing from the hash map, keeping those references in the hash set. I'm just doing this to simplify. I don't need them to be different lifetimes, do I? They're all the lifetime of the input, really. It's all bounded to that because all these rooms have borrows from that original input. It'd be a borrow check error for that because the container has to have a different lifetime. Don't see how, but maybe I'll get it when we get there. So I need to get the possible paths. That's let room equal rooms dot get current. Well, we can just index it, right? Let's keep the to do here. Yes, borrow that. Okay, so then basically it's for next room in room dot, well, in room, right? And then we check if it's visited or not. Visit is only going to have if it's a small room. So if let's have a convenience function here. Okay, I already have it there. Is small room self or self bool match self small don't care true otherwise false. There we go. So then I can say if it's small, then we need to, if it's small and visited, right? Well, if it's visited, if visited contains next room, then we continue. Otherwise, we're going to visit it and then recursively follow the path, right? So visit, so let next visited equal visited clone next, and this is mutable. Next visited dot insert next room, and then we're
Checked every
going to, oh, I mean, if I'm going to ultimately count here, then I can just turn this into a room dot map, right? Next room, and then at the end I can sum to usize. So this would be a 0, and then we're just going to return count paths rooms next room next visited. Iter. If maybe missing an else. Oh yeah, it is missing an else. Haven't covered the other cases. Actually, I guess I didn't need the is small because I could just use a match. Because if it's an end room, we don't, if it's a start or end room, we skip. Yeah, okay. I know what I'll do then. Match next room. I'll let it fill in the paths for me. I love that convenience thing there. If it's start or small and visited, right? If it's start or small room, if visited contains room. Can I not do that? This might be getting interfering. I can't do that? I have to bind it in all patterns? Well, that sucks. Okay, fine. Well, really, if it's 0, we don't go that way. If it's a small room, and it contains that room. Oh, I don't want to contain. Actually, then visited could just be a hash map of small rooms. That makes it more convenient. Right? And change where I called count paths. Actually, I don't need to, because I didn't tell what type visited was. Then it's also a 0. But otherwise, actually, if it's end, then it's a 1. End, it's 1. If it's a big room, okay, so then really move that down to there if it's big or small. Is this what I would do? Big or small room? And let's call it next room. Then this is where we do the recursive call, right? We would say this stuff down here. Okay, there I do need to move it back into a room, so hold on. So can I just say, okay, I shouldn't shadow it. I should say room here. And then I can't use that again. Hold on. Oh, then maybe that moves back to being rooms again. What was that again? It was room A. Okay, I love that the types are malleable enough. Oh, but no, I have it in 2 places. Shoot. I need to get it out. So what if I just have another method to get the name? N. Name. Self. String. Match self. End or start. Panic. What you doing? This is name. Name. Actually, can I combine these? Let's see. I think I can. I can just do that, right? Yeah, there we go. So I can just do name. There we go. I didn't need room. I did need room. But that's... Oh, then I didn't need name. Shoot, I could just do that. Oh, cool, cool. I didn't need name. I might need name, so let's keep it around. I also might need a small. Let's keep it around. So I don't have to write it again. I didn't need from string because we abandoned that. Okay. Did I do everything or did I miss something? If we visited it, then we return early. We don't go that way. If it's the end, then we found a path. If it's a big room or a small room that we haven't visited yet, okay, here's where I need this to be slightly different, don't I? These are sufficiently different that I'll just make these copied. So if it's a big room, we just go into it. If it's a small room, then yeah, we can just pass along visited in that case, right? And oh no, I can't. I have to clone it. Shoot. So they're different. They're the same enough then I just say do I have to repeat the is small? If next room is small? I hate having to repeat it, but like, I have to repeat something. I think I will just repeat the case here and just say for big rooms, we don't insert it visited. If it's a small room, we do. I hate the repetition though. This doesn't need to be mutable anymore, but it doesn't need to be a clone, which means I can just put visited clone there and remove that. So it's somewhat smaller. We don't care what the room name is if it's big. There we go. Hey there, Radon90. How are you doing? I guess TS Jost and Endoran are gone. Because they would have banned those guys faster than I did. Alright, do I need to do anything more now? If we're looking at the start room, it's like, no, we don't go that way. And we do go that way and we count it. If it's a small room we visited already, we don't count it. If it's a small room we have not visited, we mark it's visited and go that way. If it's a big room, we just go that way. And do I need this turbofish here? No. All right, great. So then, and I don't need this start room. So let's see if I got it. Oh, you're still here, TS Just? I thought you went to bed. Can't do stuff quickly on the phone. Sorry, no problem. Using enums, yeah. It just felt better. I felt better using an enum. Okay, we've failed. Panicked. No entry for key on line 66. Oh, probably because the end room doesn't have a key, right? Let's debug that. Actually, if we hit a dead end, there won't be a path, will there? Okay, then yeah, I think I know what we'll see. We'll see it hit a dead end room. No path out of it. I didn't implement debug. Let's do that. Debug. Yeah, small c. From our example over here, that's a dead end room. So yeah, I need a check there. We can't just index. I need to do a get and then return early. Blah, 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 blah. Where was that? Right here. So instead of indexing, we're going to do a get. And do a if let some room. All of this stuff. Else 0. Let the formatter do it. Let the formatter format. Okay, we failed because it only found 3 paths through the first set of rooms. Huh. Okay. One, 2, 3. Oh, what about these other paths then? Oh, it's double-ended. I need to insert it twice, not just once. We can skip the ones that go back to start, right? And we can skip the ones that come from end and go back. But yeah, you should be able to go from A to C back to A. All right. See, this is why we got unit tests. So where do I do this? This one right here, right? I need to insert it twice for certain conditions, right? If, what is it? If it's not end, I guess. If 2 dot, we'll have to make 1. If it's not end, then insert 2 to from. Actually, if not 2 is end and not from is start. So kind of like this one. Is end and is start. Start. Oh, matches. That's a good suggestion, Clippy. Does it have an automatic thing? Quick fix? Try matches. Awesome. I love Clippy. It didn't get that one right, probably because I have to save and try again. There we go. Nice. Let's try it again. Yep, passed. Let's try with the real input. 3,497 combinations or paths through it. Boom. We did it. Hey there, Crumpet. How are you doing? Let me see what I missed in chat. Rust format has made you so lazy. Exactly. Me too. Much Sarian. When I have to do C++, and I don't have my Clang format set up, it's so frustrating because I'm used to just hitting save and it gets formatted and I'm like, what the hell? Oh yeah, I'm in C++. Damn, I had to either run Clang format or just manually line things up. It sucks. Answer is 3,000. You're just suspicious. I would be suspicious too if it would. So that's amazing. You had an exact 3,000 answer. Wish there was an easy way to automatically implement all the isX functions. That would be kind of nice, like some kind of macro. I wonder if such a thing is possible. In a macro, can you enumerate all the variants of an enum one by one? Because that's all that we're really doing. Is we're doing it. We would want to enumerate them, generate a function for each with the matches, with that variant, right? So if there was a way with a macro to enumerate the variants, then we could do that with the macro. The variantly crate. There you go. Someone's already done it. Usually the answer in Rust to the question, it would be nice if we could have blank, is blank has been done in the blank crate. You could put the macro around the enum and it can do that? Oh, so we could probably do it ourselves then. I would have to remember how to do macro syntax and find out how you enumerate variants. But yeah, so we didn't need is smaller name after all. But let's keep it around because we haven't done part 2 yet. Did I miss any other chat? A squared, hi. Did I say hi to everybody? A squared, Crumpet. Fuhi, hi.
Yeah, right there.
Oh, Fu hi? Fuff hi? Fuff hi.
Colon.
Yeah, a macro that matches the enum syntax to mix enum manually, yeah. Rust analyzer has neat postfix completions. Rooms.get if full tab or match tab.
Oh no, we're gonna find
Really? I didn't know that. So you're saying if I like say like from
the enum.
hold on, up here, rooms.get I don't know.
I use our in front colon.
Hold on.
Literally right in front. You hit,
Rooms.get from if full tab. Oh, I didn't know that. Musin, thank you. That's worth 3.
that pathfinder.
So ifl and match. So the match should be like
It's like, I don't know.
rooms.match. Oh, that's neat. I love that. I gotta memorize that though, right? So it's that or
Hold up. 1/8.
the result of a get if full, if let sum. Oh, if let sum is if let sum. Got it. Neat. I don't know how I'm going to memorize that without just doing it a bunch of times until I commit it to memory. Recently discovered the joys of the format completion. Par is also a special autofill thing. Par. Not there. Oh, like 1, 2, 3 par. Well, it's parse. I don't know where you saw par. Do a match sum none. Rooms get match. So rooms get from match. Oh, neat. It's having trouble with me now. Cool. So that's one of those like developer acceleration techniques that Adam loves. Okay, anyway, part 2. I was quite happy with the progress here. I didn't get stuck. I have a neat enum with its own custom parsing, right? And then the parsing is somewhat readable, and so is the count paths, right? I need this. And I love it when these functions fit on one page. Oh, here's something. Maybe Musin knows the answer to this. It would be nice if Rust had a syntax similar to Swift, right? Where I could say if, like guard. I think that's the syntax in Swift, where it's kind of like the inverse of an if-let, but it returns early. So you like guard sum room equal rooms.get current else return 0. And then this would be like a let. Something like this. I know that it would be funky, but then the point would be that you return early if it's none, and that you get the binding on the attached value to sum rather than having to have an indent here. So then I can outdent the whole thing. Oh, it is, but it's unstable? Magic completions? Oh, no, you're talking about the completions. The let else syntax. Yes, the let else syntax. If let else is stable? So I can do that here? Because the whole point would be to not indent this. Because this 0 is so trivial that I'd like to just return it out, get it out of the way, and then move on to like not have that all indented. If let chains are semi-stable, some of them aren't. Oh, okay. But you know what I mean? Like Swift has this syntax. I don't know if it's exactly this, but the point is that there's the early return, and then the room is actually bound to the actual room is bound to that name room. Not it's not an option anymore. It basically an unwraps or an unwrap or early return. You know. It would be nice if that was there, because I've run into this frequently where it's like, it's in an option. Usually we have a big block of code, but the else is trivial. I hate having to indent that whole thing and then have the trivial case at the end, you know. Let sum equals room. So that's at the syntax. Yeah, it would be remove the if, and then semicolon, or you would have an else return 0, right? Something like that. It would look like this, and then you can outdent this, and then remove this. Yeah, that'd be cool. Like that. It's probably going to tell me it's unstable. Let else statements are unstable. There we go. So that would be the syntax. That's cool. So that's similar to the guard statement in Swift then. Cool. I like it. I can't wait for it to become stable. Because I do this pattern a lot, you know. That it will ever be, the normal advice is to use question marks so the divergent checks pass. Oh, I see what you're saying. So in this case, I can't really do it without another function that returns an option, right? Or would I map this? I don't know. I can see where that's going, but let's move on to part 2. After reviewing the available paths, you realize you might have time to visit a single small cave twice. Specifically, big caves can be visited any number of times. A single small cave can be visited at most twice, and the remaining small caves can be visited at most once. I see. So there's you can have one small cave we visit twice. However, the cave's name start and end can only be visited exactly one each. Once you leave the start cave, you may not return to it. Once you reach the end cave, the path is sent. Okay, so then it's a slight change to our rules then. And they gave us one example for this one. So it's the first example. So we only get the first example. Here we go. I need to make sure I don't make the mistake of copy pasta, which is, I have to remember to put a 2 there. And then the number is 36 now. And this is going to fail because it's not implemented at all. But we implement it naively by just doing the same thing here. We'll get the wrong answer, right? We'll get a 10 instead of a 36. Okay, so now the rule change. How do we do that?
What are the LMGs?
Count paths, like a different version of count paths? I think so, because the visited is going to, yeah, so let's say count paths part 1, and we'll have a count paths part 2. And then change that to a 2. Okay. So I think what I want to do is have like something that goes along with visited that remembers if we've like that allows a small room to be visited twice. Let me think about this. Maybe look at the example here. Like here we said, okay, B, let B be visited twice, but then we can't visit any of the small rooms twice. And then those are all the variants for visiting B. And then here's where it says, let C be visited a second time. So let's, what if I just say, if we visited any small room a second time, allow it to be, yeah, so another piece of thing into visited. So I want another type is what I want. Where to put it? I don't like to mix functions with types. We put it here. Struct visited. Rooms hash set. of room A. And then what are we gonna call the thing that the single small cave twice, like special? And then that's an optional string, right? And then this would take one of those instead. I kind of want to name it like visited part 2 or visited with special. Okay, and then we should have a default for that because down here it won't like me to do that, right?
How long is this?
Yeah, default's not implemented. Can I just implement default here?
Yeah, basically.
Because those members have a default implementation. Yeah, it'll let me do that. Okay. So then these have to be, okay, I need to implement clone. Why does that not work? Oh, this should be 2. Okay, and then contains and insert. Can I just reach into it? Wait, what? Oh, shoot. That was a hash set of strings. Because they're all small rooms. Okay. Okay, so then I need to introduce this other rule, right? It's, if it contains and visited dot special is none, then we actually go into that room, right? Kind of like this. Only we don't add it to the visited, we we set it to the special. Some room. Is that it? Let's see. I feel like that's all we need to do. Yeah, that's it. Easy. Except it's not efficient. Yeah, that took a noticeable amount of time to run. Yeah. Okay, so now it's just a matter of optimization to beat Sarian, or to try to beat Sarian, and almost get there but fail. Opt OK or will be the same as opt or. Hold on, what are we talking about? You thought this part would be shortest path, predicted that wrong, but you don't need to turn it into a result. Oh, we're still talking about the replacement for the let else, right? Or is it up here? You're saying that I don't need to turn this into a function with an option. I can take this option and do something with it. Opt or else. Oh, you're right. Yeah, you're right. I can say rooms.get or else well, it's I need to do a map, right? That means I need to map a room to that. Hold on. This dot or else 0, right? And then unwrap the thing?
I hit them.
Like that? Did I do that right? This has to be, what, sum 0? Hold on, what? This has to be closure? I can just say or, right? And what, sum 0? Did I do it? Unwrap or? Oh, good. Good. Yes. All these different variations. Yeah. I like that, actually. It did force me to make this into a closure, but I'm okay with that, actually, because it fits this. Actually, can I do a flat map here? Can I do, no, I can't, right? Bryce Clippy didn't catch that. Unwrap or default? Yeah, because the default. Of course, see, someone asked earlier who's the master at Rust, and it's definitely Musen's one of these masters at Rust, using enough to have caught all that. So I can do the same thing here, right? It would be rooms.get.map room to that. Unwrap or default. Make sure I didn't break anything. Cool. We did not break anything.
Yes, don't have it.
Now, do I want to put in the time to optimize it? I can just bench it and see, and Sarian can laugh at how slow mine is. It's like a million unwrapper defaults in your iterator code because you don't want panics and you want to make sure the bad branches are always none. Makes sense. For the Abino code, I'm taking a lot of unwrap shortcuts because it's a fairly constrained thing where they don't give us invalid input. Yeah, this is slow. 1300. So 3.9 milliseconds. And this one's going to be even slower, right? 9 milliseconds is my goal. Yeah. Mine's going to take 14 seconds to measure. So it's pretty slow.
Wait, can I pull? Don't tell me I can pull up the rampage on the. Holy shit.
137 milliseconds. Wow, I'm almost
Hold on, I wanted to.
I'm
way over there.
I'm more than 2 orders of magnitude. No, just 1 order of magnitude.
Are we gonna camp this
At least I'm not 2 orders of magnitude. At least it's not a second and a half or something. It's 137 milliseconds. It seemed to take longer than that, didn't it? Oh, because it's a debug build. And right. It's faster bench because it's a release build. So if I did run release, it's pretty quick. Okay. All right, so then I'm pretty sure a lot of it is the clones. If I can think of a way to not clone, that would be nice. Oh, yeah, it's only about 10 times slower. Yeah, you're right. It ran debug profile on the normal run. Can't you bench and release? The bench is release. When I run bench release, it's the release build. Are you asking, can I bench the debug build? I think if you do the -- debug, right? Am I right about that? Imagine most of the time is spent in cloning that hash set. Yeah, this one. I just couldn't, I just didn't want to think about a clever way to avoid the clone. I mean, I guess we could accumulate what we're adding and then remove it back out on the way out. I could try that. Most of the time it's done creating the closure. Nah, this is not a dynamic thing. This is static. Most of the time probably is doing this clone, like Musen's saying. Also hashing during lookups. So to avoid hashing, I need to make my own container that has special knowledge of this enum, right? So what I could do is since I know the number of rooms, that's bound, right? There's no more than 22 rooms. So I could turn the room into an 8-bit number, and then just have a sparse array of them. Maybe that would be faster, right? The hashing itself won't be awful. Okay. Well, let's see if I can remove the clones. I have one idea on how to do that. I didn't actually need this after all. So my idea is that instead of cloning it, we borrow it, but we also, on the way out, we remove what we inserted. Yeah, let's try that. So then I won't. So when we let's do it on part 2. So we won't own it. We'll just mutably. I'll just be lazy and give it the same lifetime. Mutably borrow it, and we don't clone.
Yeah. Are we actually?
Next visiteds all become just visited. Don't clone. Don't clone. Okay. Oh. Wait, what? Oh, they are different lifetimes, right? No, this should be. What's its problem here? Why did it expect underscore? I mean, I guess I can give it a different lifetime. There. I gave it a different lifetime. Alright, since that's mutable reference, we have to mute that. There we go. Why did it need... Why couldn't I reuse A there? That's... It's often a little weird. Why would it be weird? It's just saying that it can't outlive A lifetime, which I was just being lazy and saying, okay, they can't outlive my input. Really is all I'm saying with the A, because ultimately A came from my input, is anything I make can't outlive input, which is guaranteed by this, right? Because it's all ultimately called from a context where it's it lives less. It lives less time than the input, because the input has to exist for the whole duration of the function call. So I don't get why I would need a separate lifetime for the borrow on for visited. But anyway, I decoupled it. I didn't have to say where A outlives B. I could say that, but I didn't need to, because really I shouldn't need to say B there. A should work. You don't even need a lifetime on that bar because it's not sharing. Yeah, actually, yeah, you're right. Because I was able to put an arbitrary B in there, you're right. I don't even need to say the lifetime of that. You're correct. So just leave it like that. I could probably also do the same thing for some of these other borrows too, right? Let's see. Can I do that? Yep. Can I do that? Yep.
Aim straight up.
I can simplify the lifetime stuff. Yeah. I do need the A to go into the room though, right? And I need that there. Can I say that? No, that has to be A. Because these ultimately have references, or this ultimately is a generic, so that it needs some lifetime, and yeah. I'm still not completely comfortable with what that means, because is it the first one, or is it just anyone that will fit? I don't know. It obviously doesn't work if I say figure it out, because then it's like expected one there. So I'm like, okay. All come from the same string, yes. All right, so the special I add, I have to take it back out. So let count equal visited.special equals none count. So we'll just undo things as we back out. So it's here, right? Let count equal that. And then visited.rooms.remove. That should work, right? I'm just undoing my work on the way back out. Yeah, so let's see if that improves the benchmark. Tick underscore computer tick A is the same as, yeah, that I know, but then why,
That's crazy.
when I made it,
Yeah, they just
why when I make it implied, can't it just figure, oh, I see what you're saying. Yeah, if I make it that, then it becomes as if I put a B there and did that, right? Then I get the same error. Yeah, okay, I see what you're saying. It's like saying, it's probably because I have to put something there, right? If you have to put something there, but it could figure it out from some, like, as if you had put, as if you had not put it like, okay, I get it. I can't explain it, but I think I get it. It will introduce a new lifetime if there's any other lifetime existing. It's how lifetime collision works. Lifetimes count more than once. Yeah, so I'm this close to understanding what you're saying, I think. But what Sprudeldel said gave me a bit of insight that it's analogous to this one, right? That's
That's not the one.
in an inferred lifetime, where this is, where if I had B there, it's an explicit lifetime.
Here.
And when it's inferred, it doesn't use a named one. It just makes a new one. I can understand that. Hey, look, we got it 25% faster. It's still not on par. It's still an order of magnitude slower than Sarians, but that's an improvement, right? Remove the clone. So then does that mean that
Get out of this area.
I really am having a lot of performance hit with insert and remove? So then the next step would be not to use that container at all.
Was it right there?
For more than one lifetime going in, they each get a unique anonymous lifetime, but now the out lifetimes must be explicit. And that's where you have to have the tick underscore. Okay. I don't know what existential types is.
Well, he's
I wonder how long our parse input takes.
again.
It probably doesn't take very long, right?
Doesn't have ammo.
To measure without the parsing, and I'd have to do like I did before and have like part 2 no parsing or something, or part 2 parsed, and it has to take one of these hash maps.
No, I'm after the solo right.
And then it just does this part.
I'm out of light ammo though.
Pub what?
Need it.
Can't leak.
There.
Private type. Room. Oh, yeah. The consequence of that is my room has to be public. And that means, because we're going to use parse, parse input needs to be public as well. Because we're going to call that from the benchmarker. So let's add a benchmark without parsing.
I'm getting sniped at from the room.
NP, no parse. So here, we're going to parse once and then benchmark it. So let rooms, it's just copying from here, right?
Thank you.
I'll fully qualify that. So
How to use it.
AOC 2021 P. Oh, that's right. I hid it behind this. So where's day 12? Yeah, I did this kind of a thing.
I got one.
And then
Don't go in. Just don't.
day 2 parsed. The part 2 parsed, SP12 2 parsed. And then, yeah, I need to make that input public.
Wait,
Okay, so then this is what I use from the benchmarker on this. Oops, no. Nope, 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 nope. That, hold on. This is what I call there.
Give me the wingman.
Yes, iter with
People here.
that.
Give me all this shit. Top, I need this.
Let's borrow that. Can I import that? P12 input? Hold on.
I need to just
Not hit save. Oh, wrong function. Yeah, I keep screwing that up. I need to parse input needs to be imported here. P12 parse input. There. Okay, now I can run it without parsing. Here we go. Was cloning the visit state, just understood how
Here we go.
to not need the clone. Wait, what? Oh, yeah, so it's slightly better. So what, from 105 to 99. Still an order of magnitude off. It's not really the problem, right? Yeah, so I'm doing something very slow. I mean, the only thing I can think of is that I'm using hash map hash set, and it's just doing a lot of hashing. A lot of hashing, a lot of searching. Ultimately, though, we could reduce this into an index. So it could be an index going in. I don't. It seems like a lot of work to me to do this right now. So maybe I make this an exercise for later. Doesn't VS Code or a Rust plugin have some performance profiling to see hot code paths and functions? Not built in, but I'm using the, what is it called? The criterion crate. Even with that, you have to set up the functions that you want to benchmark. What I've seen other people use are like Very Sleepy or some other like external tool that operates on the program itself, and you just build it with symbols, and it will show you the hot paths and stuff like that. So I used that before, and I could do that now actually. I'd have to make sure I build it with symbols. Oh, I think I'm already doing that. Oh, I guess I removed it. At some point I added it. I think you had to add it at the workspace level. And then I could use Very Sleepy on this and see what it looks like. So, let's not use Google. Let's use DuckDuckGo. Rust, no, not Rust. Yeah, Rust release with symbols. I just forget what it is. It's something at the workspace level. Someone will probably tell me before I can find it. Yeah, it's this profile release debug equals 1. and then build it. So cargo build release, and then I just run it through very lazy or very sleepy, something like that. So file launch. What was this? 12-2. There we go. It only ran it once though. Yeah, hash map, right? Yeah, see the hashing stuff is the top. So I'd have to rewrite my code to not use hash map, hash set, I think.
Oh, wait. Shut up.
You can make a new profile now, profile.res with debug, op level 2, debug true. Hey, there you go, Ist. You can change the hasher out. That's an idea. So yeah, the default hash is doing a member-wise hash, right? Well, we only have a couple members here.
That's what happened.
I think it's just expensive to be hashing these strings so much. If I reduce the input to an index and then hash that, it might be better on its own, right? So I could try that, because we don't really care about the names of the rooms anymore, right? Yeah. What if I just change these? In fact, that'll simplify the lifetime significantly, right? The room doesn't have to have a lifetime anymore because this is just a U8, right? Another U8 there, right? We don't need this anymore. The parse is still a string, so but it's a lifetime we don't care about anymore. And then instead of this name, I need to have some kind of table of names we've seen before. So that's like names, mutable reference to, well, this we only use at parse time, so it's not going to be that bad, right? Have I been plugged? Something has been plugging my stream in my house. Okay, so I'll have to do it twice, but that's okay, right? Yeah, we have to look it up, and if we don't find it, we need to add it. So let I don't know, I equal no, then it can't be a hash map. It's got to be like a vector, and we just add it at the end. Yeah, it's names.find. There's no find on vector? Really? I thought vector would have a find. FX hash wouldn't be faster. Use FX hash. It's what Rust what? Uses internally. I'm gonna try to do my approach to see if it's any better. I thought vector had a find in it. I guess I'm wrong. Is it that it's in slice? Is that why it's not in vector? Slice find? There are too many things called find. Isn't it? It's like find? Okay. I should just do what I did before. DuckDuckGo, Rust Vec find. Oh, there's an iter. Okay. So it would be like names.iter enumerate find I comma name, well, existing name, where existing name equals name. Find map. Yeah, I finished the challenge. We're just doing optimization right now. So find map. If name equals name, then sum I, else none. Which actually turns into existing name equals name dot then I. Okay, and then we say dot unwrap or else. Names dot push name. Names length minus, well, -1. Right? And it's just big I. Okay, so this is complicated enough that I kind of want that to be its own function. So let's do that. Where to put it? Down here, I guess? After all my types before other functions, so find or add. This can be completely generic, actually. Vec is some mutable reference to a vector of t's, and then there's the owned. It's going to be owned, right? Yeah, so value t, usize. All right, and then put all this in there. Instead of names, it's vec. F2. How come you're not working? Instead of name, it's value. And this should be like existing value. All right, and then find or add. This seems like a useful thing to have. Find or add names, name. And I can actually read it. Okay, so these rooms don't have namespaces anymore. This becomes a U8. I don't even think I need this namespace anymore. I don't think I need that anymore. Yeah, I didn't need that to begin with, right? Part 2 doesn't have that at all. Yeah, so room visited with special also doesn't need that because this is also a U8. So that doesn't need names. It doesn't need to be generic over any namespace. So that doesn't need to be generic over namespace. You pulled in a string interner because you're too lazy to handle that bit. Oh, did you? I'll be happy, Sarian, if you're telling me that you did the same approach where you just kept it as a hash map hash set, but you just removed the strings and just made it integers. Because that's what I'm hoping here. So parse The oh, this finder ad, it is use size, but I can cast it, right? Because I thought the smaller the better. I don't know if it really matters. Same thing here. I need to do that. And then put there, and then this is I as U8. All right. What else do I need to change here? Okay, so this has to be T, where T implements equal. Or just need to be partial equal, I don't know. And then we need to dereference that. Can that just be partial equal? I think it can be just partial equal, right? All right, and then room parse takes 2 arguments, right? Because we need to have our memory. So well, we're gonna toss it when we're done. So let mute names equal hash. No, it's a vector, right? And then those go there. Borrow them mutably. There we go. Moving on. Insert room. Dereference the room. What's kind of cool is you can change, when you change types, if you do a lot of type inference, not a whole lot needs to change in the code after you change the types. Those stars like need to be there because I went from a reference to an owned value. For this, it's an owned value, not a reference. They could have been a dereference before, it just didn't need to be. So let's see if this still passes my tests. That's one of the things I really like about Rust, though, is if you use a lot of type inference, then you can change the types almost fundamentally, and you don't have to really touch a whole lot of the logic that uses those types. So, like, my actual counting didn't really change much because it doesn't care. I don't actually use the type of the room name anywhere. It shows up in the inlay hints, like here, but I actually never said it had to be a string or a U8, right? So I could change the type, and it just kind of magically all works. I love that. So let's bench it again. Without parsing, to be fair. Compare with Sarian. No hash maps in your impl. Okay, so mine might be slower still. But I'm just kind of curious, because hashing the strings over and over again, that could be a lot, right? The strings aren't long, but it's still doing a lot of calculations it doesn't need to. Wait, it's still going to hash my U8s, though. So I could make an implementation that doesn't actually need to hash because the numbers already are unique. Looks like I'm going to have to because it's still slow. It improved a little bit. We're now down to 78 milliseconds. Okay, so let's try to remove the hash set next. The hash set is where rooms, right? So we know there are only like a small number of rooms. I could just use a sparse array here, right? An array of booleans. We know how big it is when we parse these names, right? The length of this vector will be the boundary on how big we need to make our hash sets. So actually we're returning them here. We know the size. You know what I can do is I can have them start out as hash set, but then reduce it to oh wait, no, hold on. It's not just these big and small rooms. There's also the end and start room I have to worry about. Well, still, like, I could just use room. And map. I could just have a map from room to integer. That's what I can do. I just need to know the upper bound of it. Well, I can do that during construction, actually. Yeah, let me try to make something about this. So, struct room set, right? It has, I guess just for convenience, we'll have a vector rooms. And, actually, why am I doing this? I can have small rooms, big rooms. And then it doesn't even need to be a room. It can be a vector of booleans. And we'll use the index of the room as index into the smaller big rooms. There we go. And then we just need to remember is start in the start is a bool, end is a bool. Yeah, I like this. So then we'll just use room set in place of hash set room. So these become room sets. That becomes a room set. Basically, I replace the type, and then I have to fix it up wherever I need to implement something hash set did for me before. So like the methods like contains and insert and all that junk, we just need to implement all that stuff. So this is room set. Okay, so let's chase down the errors. So like or default. There's no default for, I had to implement default. Can this just implement default by derivation? Because that's sort of what I want, right? Everything empty. Okay, and then I need an insert. Easy. So, impl room set. Function insert. Mutable self. And the thing we're going to insert, which is a room. So, room. So it would be match room. If it's a big room, no, let's just do the easy cases. So that's self.end equals true. This is self.start equal true. This is big I. I have to do two things, right? I have to make sure self.bigrooms.resize? Is that what it is? Resize, not resize. What is it to expand it if it needs to be expanded? Uh-oh, what's all that? I think that's the sunlight reflecting through my blue screen here. Those weird artifacts. There's not much I can do about that other than close the window on the other side of the house. If you guys don't mind the weird glowing effect, I'll just leave it up there. It's not resize or reserve, right? I mean, I could just do it with resize. I can say if I is greater than or equal to self.bigrooms.length, then resize it to that I plus 1 false. I can do that. Expected U8. Expected U8. Oh, because I is a U8. Let index equal I is U size. And then else. Actually, after that, I have to do self big rooms index equal true. But there's got to be a shorter way to say that. All right. Anyway, once I remember what that is, I'll put it there. That's an I. This is a small rooms. Okay, that's insert. Now I need iter. Okay. Iter is going to be fun. Let's do iter last. Let's do contains next. For contains, it just needs, oh, it needs to be borrowed. Oh, because before I had made it a copy type. So we'll improve it at the same time by not making it a copy type. Is this the same thing? Yeah, we need to borrow here. I was taking advantage of that it was a copy type.
I believe in you, CJ.
Yeah, that's a U8 again. Is it the same thing here? Borrow, borrow, and a borrow. And borrow, and not, and...
The piggyback bread spoilers.
Okay, so room, or remove room, that can borrow. Well, it's just going to be a U8. Hold on. U8? Hold on, that is a borrow then. Okay. So then I just need to implement iterator and I'm done. That was easy. The whole thing was just to fill this in so that we can iterate the rooms. Implement. I always find these fun, implementing iterator for room set. The item is a room. The next is to, oh, wait a second. I don't want to do it this way. I want to implement into iterator because we have to make an iterator that has our iteration state into iterator for, let's have the actual warning tell me what I need. Oh, shoot. What is it? It's not telling me what I need because iter is actually a different function on every type. Is it into iterator? Is that what I want? Probably. The item is a room. Into iter is room set iter. Struct room set iter. Rooms. Room set. And then we need to remember like which stage we're on. So I guess we'll have an enum for that. Room set iter stage. Start stage and then end and then big rooms, small rooms. And why don't we just have an index in here? Then we can just like define the progress through that. And it needs a lifetime. Am I doing this wrong? It doesn't go there. It goes there. No, it doesn't go there at all. Shoot, then where do I put this? Is it here? Oh, I forget how to implement into iterator. I should just look it up. Into... Show me an example. Oh. I don't need a lifetime there at all. Wait, then how does that work? I need to declare a lifetime there. So we return the type that implements iterator. So did I just this is not a trait that I need to implement. Yeah, okay, never mind. I don't need to do that. I can just, yeah, you're right. I can just implement iter here. self returns a room set stage iter. So room set stage iter where rooms is self. And then I need a, it's not stage, it's iter. And it's gonna need a lifetime there, right? No. This becomes the implied lifetime. Okay, and then stage. One of these guys. And then I have to say which stage. So we'll start at the start. Okay, so then map, because it doesn't implement iterator. Yeah, okay, like I'm back on track now. This one implements iterator for this type. Implement item is room. Next. Private, oh shoot. So yeah, all this needs to be public, right? Hold on, what needs to be public? Room set needs to be public. Okay. We're getting there. It won't need it with elision, clipping my complaint. Oh, you don't need that anymore? This, they don't need it anymore? I thought you needed it at some point. Okay, you're right. I should just throw Musin some more points. Thank you, Musin. Alright, so then, this depends on the, room, the stage. Match. I guess we'll just consume it going in. So, self.stage equal, oh, hold on, let's, It's mutable. No, but I want to take... Alright, I can't pull it out anyway. Shoot. Match... Or... Okay, that does work because it's ending up... I'm surprised that it, let me do that and didn't give me an error, because doesn't that consume stage? Oh well, I won't worry about that. So for next, actually this needs to be while, or just a loop really, or while. There needs to be an end. Actually, I guess I could just say that. While, no, we need to hit end once, so then done, I guess? While, I guess just loop. And then put done in here. Have it return none. Okay, and then, because these depend if start is in the rooms, so if self.rooms.start, we need to advance the stage though. Okay, really what I want to do is, for a stage, tell me what the current stage is and advance to the next one. So like, let last stage equal self stage dot advance. And oh, it needs to know, it's going to need to know the maximum indexes. So, shoot, this is more difficult than I thought. Okay, never mind, I won't do that there. It won't consume self, well, I was wondering if it would consume stage. It'll say I moved out of stage. Because that is, it's an enum. But it might warn me about that later. But for now, we'll just go with it. So I guess we'll just say self.stage equals
Big migraine.
end next, and then if it start, then return room start, or some room start. And end is similar. Big rooms 0. Actually, this depends if we have big rooms or not.
No, he took
What I want is a method on room set itself to say what the next room is given a certain stage.
literally anything.
So like next
I love bridges.
room, well, next iter stage. That's what I want, and then I want to match stage.
Yeah, then no more bedtime.
This can borrow that, right? So then done is done. Start is end.
First, similar to mechanical.
End is, this is where it depends, right? If self dot big rooms is empty, if self dot small rooms is empty, then done. Else small rooms 0. Else big room 0. All right, and then small room.
Allegedly.
This is an I. Yes.
Allegedly.
A lot of code to implement your own custom iterators and stuff. If I plus 1 is greater than or equal to self dot big rooms dot length, else, so it's either the next big room or it's this first small room, depending. Actually, it could be something else. So this is I plus 1, right? Otherwise, it's kind of somewhat, it's this, right? Like that. And then small rooms is similar, only a little bit easier. If the small rooms, we're at the end, then we're done. Otherwise, it's the next small room. There. That's the iteration sequence. So that being buttoned up into next iter stage, I can actually get it right here. Let next stage equal room, well, self dot rooms dot next iter state self dot stage borrowed, right? And then that out of the way, this is where we put down here self dot stage. Oh, but I have to do that before I return. Shoot. Crap. Put that before we return some. There. Nope. What am I doing? It's right here, isn't it? There we go. That's what I meant to do. Just taking a long time to do it. Okay, big rooms, I. So we do that, but then we say if self dot rooms dot big rooms I Return some room big I as you ate. All right, and then the same thing for small rooms, only it's small instead of big. Small and small. All right. I think that's it. There's a lot of things to test, though. I kind of feel like I should be making some unit tests. Or I can just go for it. Let's just go for it. Oh, it failed. I got 0. Okay. So there's a bug somewhere in all this iteration stuff that I did. I just don't know what. So do I make unit tests for that, or do I use debug? I don't know. It's saying that there are no paths.
I hate it. This sucks.
What if I just do a lazy approach, implement debug on this, and then every time we do an insert or something, I can do print line before self Wait, what am I doing? Should just go left to right. Room self. And then after. Let's test insert. All right. Oh, nope. Something didn't build. Oh, that should be debug. All right, now will you go? Go. Small one. Oh, we have... I mixed the big and small rooms together, looks like. That's okay. Small 2, false, false, true, big 0. Yeah, that's correct. I notice we never actually put start in this set. Is that a problem? Before end, after end, end is true. Is this what Enterprise Rust looks like? Wait, what happened? Oh, big rooms had a true in there. So I don't think insert is a problem.
No, it's game.
So maybe iterate the iterator?
I could start.
So, like, can I say just debug around the whole dang thing? And I have to implement debug on this. All right, we got a lot of text to look at. Too much to see, actually. Okay, this, yeah, it's too gross. So instead, let's just say let next equal that next, and then we'll just print something here. Print line goes to stage next. All right. Start goes in and big rooms, small rooms, start and Okay, let's print out the actual rooms though.
Fun. Like a sleep
I'm having trouble with my keyboard. Self. All right, there we go. Start goes to end. End goes to big rooms. Yeah, big rooms to small rooms. Yes. Start to end. End to small rooms. Small rooms 0 to 1, 1 to 2. Start to end. End to big rooms. End to small. 2 to done. Yes. Start to end. And this all looks good. I don't see any errors here. Yeah, I don't know. I'm wondering if I made some silly mistake up here. Stop printing that. Remove this. And the let and all that. How about putting a debug here, see what the rooms are. Each step we try another path. Okay, it's hard to see that. I need to see that and what the visited is. Okay, so let's print out just a bunch more junk. So then extra level here, and the print line. Visited current.
Sword twin blades.
Run test.
Yes.
It's just never getting to end for some reason.
Give me money.
It's never getting to the end. Why not? Like, Big Zero should be okay. What's wrong with that?
What is that?
Oh wait, why do we have a clone here? Oh, because I left the clone in for part 1. Part 2 I removed the clone. Anyway, it's getting noisy around me. Can you guys tell? You can hear all the chatter around me, coughing and stuff. How long have I been going for? 2 hours? I should probably end soon. I'd really like to figure out what I did wrong here and be able to benchmark this though. Oh, I should print out the current. So this is visited. This is the current, and this is the next. I don't need that extra question mark. All right, let's print that out. Yeah, I never see a next where it's the end room. So what happened to the end room? Did that get parsed incorrectly? I think it did. I think the parsing is not right. Let's print out the parsing. Parsing, where are you parsing? Up here? Yeah. Debug. I want to see those rooms. I guess I don't need this anymore. Well, there's from big to end, but it's just never enumerating it, I guess. Oh, wait. Where do we start in the enumeration sequence? When I make the iterator, start. And then what's the next from start? End. Yeah, shouldn't we have hit the end a bunch of times then? Wait, this is not even right. It should only be the start if okay, this is what's wrong. Yeah. It should start on an actual room that's there. Well, no, hold on. I actually included that always, right? And it's if we're in that state, here it is. Then we have an if to check it, and that's why we have this loop. Oh, there's my bug. End. That's why we never hit the end, because I copy pasted that. All right. That's what it was. So, shoot. That took a long time to find. Yeah. We never had an exit. That's why it told me there were 0 paths, because the exit looked like the start rooms. Okay, that's what it was. So does part 2 pass? Yes. Okay. It's always something like that. Let's benchmark it. Hopefully this is faster than, what's the last one, 78 milliseconds? It's still slow. It regressed. No. Hash set is better than my custom implementation. That makes me sad. I know. It's very sad. Well, we're still using hash map. But I guess I didn't really need room set. Well, I already discovered that the numbers in big and small rooms don't intersect. So I can kind of cheat and reduce the room. I can implement hash in terms... I can implement hash myself. Yeah, why don't I do that and see? Because that'll be a quick thing. Implement hash myself. What's its... how come it doesn't even know where to get it from? Standard hash. Oh, that's not what I want. What I want is to just import that. Use it. There. Okay, so then... actually never implemented hash before. Okay, see ya. Self ID hash state. I don't want to do that. Oh, I can just say, I can reduce it to an U8 and then hash that. That's how I'll do it. So, yes, self, well, match self. Let, well, it's match self something dot hash state. Whatever. Fill in this. So we'll just map start to 0, end to 1, and then big will be 2 plus n. And then small will be 2 plus n plus self dot. Oh shoot, we don't. So it's some sufficiently large number. 65536. There. How come it didn't like that? I gotta implement partial equal myself? Okay, I can do that. Why did it fill it in like that? Interesting. I mean, that's sort of what I want. What does mem discriminant do? Oh, it just looks at the variant? Oh, that's interesting. Actually, I kind of like how it just kind of figured it out for me. What is it? Oh, because it's U8. 128. Okay. Mess it up or no? I have a feeling that this is not going to really help. Hey, meme clairbams. You've implemented hash if you know what you meme. Yes, I know what you meme. But it's not yet 420 where I am. It's only 332. It actually got a little bit better, but not really. I think I'm splitting hairs and not attacking the real problem, which is probably the hash map. But I've been trying to avoid having to hit the hash map. This guy. Well, you know what? I can make just an array. That's what I can do. An array. Yeah, we'll do this. So because we know room can be reduced to a number. So in fact, I'll move that into room. So this thing. So we'll just say function hash. Let's call it something different other than hash. How about unique or ID? How about just ID? And then we can say up here self.id. And then actually, we're not going to need that hash implementation in a minute, right? So let's just drop it now. Put that back in. Just drop all this junk. Because we're going to implement our own struct room map t. So that's just going to be an array. Slots is an array of 256 T's. Option T's. Okay, then implement. Well, hold on. Let's see if we can just hash map room set. Let's just replace all of that globally with room map to room set. It didn't hit it everywhere. Let's try that again. Match all. Oh, I see. It's not hitting that one. So I can redo. It's this one I have to do manually. So it's just this. Oh, and then I don't need the room argument. Okay, so what do we need? We need new. So this could just be defaulted, right? I think we can derive it. It's just a bunch of nuns, right? No. There's no default for an array. Well, we'll do it ourselves then. Or do I do it this way, where I say T has a default? Can you put it in here? No. Is it... Oh, let's just implement it. I don't know how to do it with the derive. So implement default for room map T default. So slots would be T default 256. Can I not do that? Needs an option. Oh yeah, none.
Yeah.
Anyway, now we need entry. Oh crap, entry's complicated. But we always use it with or default. So what if I just make what if I just replace all that with just an insert? Actually, why did I use entry or default? Why didn't I just use insert? I don't know. I don't know why. Oh, because it needs yeah, why didn't I do this before? We need a get and we need an insert. Fair enough. So let's do get first. Map function get self room option T. We'll say let ID, well, it's really just self.slots room.id, right? And can index, so it's as usize. Right. Actually, get returns of that, right? Just want to borrow it. As ref. One of those mystical things to turn a reference to an option T into an option of a reference T is as ref. Oh, my get needs to borrow the room. All right, and then we just need to do insert. Insert function insert mutable self. Key is the room we own it, and then the value t. Self.slots room ID as usize equals some value. All right, now what? The 2 is... Wait, what?
I got gold.
Found enum. What did I have here before? Oh, I did want... Okay, yeah, this was different. Shoot. I wanted to get the entry...
I have 34 right now.
Okay, this is a little bit different. This is a little bit different.
Literally, you already...
I don't want exactly insert, do I? So I don't want to call it insert, and it's
just such a good defense.
this only works with... Okay, so then I don't really want this to be generic.
Push, that's not a balloon.
I want this to be room set. And yeah, this is option room set. Actually, then it's just room set, because the room sets can be start off as empty, right? Yeah, that makes it easier. So then, get rid of the generics. So then this is just room set default. And this is room set. No, this is where it's not insert. It's like add room. Where is this used again? They're not both rooms. What are they? Oh, from to, right. So it's insert add path. That's what it is. Gah. This is add path. And then up here it's add path. And this is from, and this is to. Okay, and so this is from, and so on that I want to do insert to. Yes, okay, what's the warning here? No warning. What's the error here? Right, so room map, the generic goes away. Room map is just... So it's not really a map anymore. I should call it something different. It's really paths, room paths. Paths. And this is like, well, I guess, I don't know what to call it, because this is like, we index the from to find the set of destinations. What's wrong with this one? Oh yeah, those are not options anymore. Where is get used again? Just do an unwrapper default, so then I can customize my get to always just return something. Yeah. So this just becomes a room set borrowed. And there's no as ref. Shoot, why didn't like, oh, borrow from that, please. Yes. All right, and then down here we don't need to do a map. It's just rooms.get.iter. Yeah. .iter.
How are they gonna run fast?
We don't need this default anymore. Extra parentheses? No.
Maybe like
What did it not like about that? Oh, one fewer. There we go. And then down here, the same thing. It's just iter. and remove all that. This actually cleans it up quite a bit. And what's my error here? Probably room set doesn't have a default. Oh, it's not copy. Really? Oh yeah, not copy. Yeah, shoot. How do you do this? I mean, that's the only place that's going to copy it, and that's only on the default, so we'll just take the hit. We'll make it a copy type. Where is it? A fancy array map? Yeah. I'll just take the hit and make it copy and clonable. It cannot because it does the fields to implement copy. Shoot. We can't do that. Okay, then I'm not going to use an array because this is too hard. We're just going to make a vector of them. So that's just, okay, that's a vector. And this is just, then this can be implemented directly. There. Okay, this needs to be public. And we don't use hash map or hash anymore. Something's using hash set still. Oh, that's fine. Okay, make sure it still works. It doesn't work. It panicked. Out of bounds. Length is 0, but index is 0. 69. We crashed on line 69. Oh, I forgot. I don't want to do default. Shoot. I don't want to derive default, actually. Because we need to pre-allocate that. So don't do that. So implement default for room paths. It self-slots vec room set default 256. Is it going to be the same thing about the copy? So then I just have to do a loop, right? Let mute slots equal vec reserve. Oh, it's vec with capacity, right? 256 for something in 0 to 256 slots. Push room set default. I know it's ugly. Head tech don't really need that, right? Just do new. Not the function. Call the function, please. There we go. Now run. Yep. It runs. But how fast is it? We have no hash map now. Now it's just an array lookup. So, I mean, it should be a lot faster, right? If not, maybe I'll cry. I think I'm gonna have to cry. It doesn't look like it's any faster. Okay, a slight improvement. Vec macro only needs clone, not copy. Oh, I missed some chat. Thank you for explaining to Thank Skeleton what I'm doing. Yeah, I finished part 1 and 2. I'm just trying to optimize my stuff because it's slow. Sarian has got this running under 10 milliseconds. So I'd like to get under 10 milliseconds. So I might just have to give up though and just go with the fact that I got it done. It's just a little bit slower than Sarian's. Where are my stats? So I didn't do it on time, so my rank is terrible. But and I didn't run a stopwatch. But I think I did pretty reasonably good job. It's just this optimization. I'm failing to get it fast. Oh, I could run. I can make a release build and run this in the profiler again. Build release. Where's that? Build release, and then run it in the. I use Very Sleepy to run this. File launch. Same stats, right? Launch. There we go. Okay, so it's going into my next function for my iterator. A lot. Well, that's cool. It shows code down here. Why would that be slow? Oh, is it doing a copy of something big? What line is that? 183? Go away. 183. So this is a hot point. Why would that be a hot point? This is a fat type, maybe? It's just an enum, so it shouldn't be really that big. The size of two U sizes, maybe? I guess I could reduce this. But that shouldn't be a problem. Why is that? Why is that taking a long time? Why is that line taking a long time? This should just pass through one. It should just pass through. There's no loops at all. Why is that slow? Close to that 2, part 2. "17 milliseconds," you're saying? Yeah. I'm still on the order of 100 milliseconds, so I'd like to get it faster. I wonder if this is just because it's only running it once, and I just run the profiler hundreds of times. I had a trick for that, right? In the main program. Where was it? Did I already delete it? I had like where I could just, in the main program, run it a gajillion times. I mean, I can just add it. Profile. And then just run it a million times, or maybe not a million times. How about 1,000 times? What's 1,000 times 100 milliseconds? That's too many. How about 100 times? Be like 10 seconds? Anyway, we don't actually have to print anything, right? We just need to say 4 in 0 to 100. Actually, I want to not redo the parsing, so let me steal what I did for the benchmarking, and do that there, and then just do this part there. And import that. Oh, wait, what? What's the error? Expected string. Okay, so turn it one more time. Oh, wait, no, what is it actually expecting? Oh, yeah, that's what I did wrong. I should just look at the error messages before assuming what the error message is. All right, so then build release, and then I'll change the Very Sleepy run so that when it launches with the argument 12-2-profile. Now launch. Okay, it's profiling it. 6 seconds elapsed. 9 seconds elapsed. 10 seconds. Did I do too many runs? 100 times 100 milliseconds. How long is that? Oh, it's done. It still spends a lot of time iterating my iterator. I don't know why. But looks like the hash map is still top, so that's because I still have one in here. I'm plagued by hash maps. Or hash set, right? So it's this rooms visited. I guess we have no choice. We must remove them. So instead of hash set, it's just going to be an array of bools, 256 of them. And I can't derive default on that. So I got to do it myself. Derive or implement default for visited with special. So rooms we can default, but no, we can't. Rooms is the one we can't default. So that's just false 256. All right. So we need to implement contains, insert, and remove for, okay, no. These we just change, right? Or should I just wrap it first? I feel like I should wrap it. So instead of, yeah, let's wrap it. Struct room. I already have a room set. Why am I not using room set?
You also are watching the net special?
Because these are small room. This is small room set.
Yeah.
And then move that there. And then this becomes that. This becomes that. And that. Move that up here. I can derive default again. I need another self. Clone is not satisfied. We can do that. Clone. Okay, now I can implement contains, insert, and remove for this. Implementation for small room set. Function contains self room. Actually, it's just U8, right? Bool. It would be rooms room as usize. Self rooms. Okay, then we got contains done. Oh, I don't need to borrow it. Well, we can though. That conforms to the interface that usually a contains does, and then insert and remove. Okay, we can do this. Insert, mute self, room, U8. It's kind of like this, only we set it to true. That equals true. And then what's wrong with this? Cannot be dereferenced. Oh, we already are sort of getting a dereferencing it because it's the indexer does that. Okay, so then remove. Here we borrow U8. That's the normal convention, right? And usually I return an option, but I'm not going to even bother with that. It's just that dereference there equals false. All right, and then unit tests. You know, it'll be just like what happens to me usually, where the last thing I do is what I should have done first. Let's bench it first. No quality settings? No, I don't get quality settings as much anymore because I am not an affiliate of Twitch. No more. Okay, I think it's a little faster because it says it 300 iterations in 5 seconds. Oh, there we go. 18.4. We're getting there. Let me build with a release build and look at it in the profiler. Very Sleepy is still open. Let me close it. All right. Actually, I guess I could have just told it to run again. Launch profile. It's going to do it 100 times again. It's running, it's running, it's running. 5 seconds left. Here's the runner. Yeah. Okay, cool. No more hash map. And our critical path is going the next in our iterator. Okay. Here's where, like, I don't know, like, where the hot path is here. We do spend quite a bit in this next iter state, which we don't always need. So I can optimize that to be, we only calculate it when we need it, because we don't need it for done. Actually, we need it every other place. Wait, these are just booleans. I don't know how I could optimize this any faster. Actually, I know how I could optimize this faster. I already had this idea of mapping the room to an ID. What if I just reduce this to just IDs? Close that. So like close that. So yeah, again, I've been going on the last, I don't know, hour and a half, maybe 2 hours, optimizing the solution for Advent of Code day 12. I already finished it. I got the right answers. I'm just trying to make it fast. Where is it? The iterator I made. Down here? Yes. So I can just, like, this stage thing, I can just remove it. Right? I don't really need it. I can just go from an index from 0 to 256 and say we're done. Right? Let's just do that. So there's no stage. This is just a U8. The next is just the current stage plus 1. Actually, we can just have an early return here. If self.stage is 255, return none. Wait, what? Oh, equal. And then I don't need all these matches and junk, right? Well, the stage is 0 is start. But only if yeah, it's this one. That's 1. This is n if n is less than 128, right? Here's where I had some magic numbers. Where was the 128? There it was. Here's the magic numbers, right? So big numbers start at 2, small numbers start at 128. So that's, yeah. And so this is n. Big rooms is n minus 2. Well, I just say let I equal n minus 2 as U size. This should be I. Correct. Well, then I don't need this as there. I can move it to there. Remove that. Okay, and then this is similar, only it's let I equal n minus 128 as U size. Remove the as 8. Okay, whatever this stuff. Okay, so then the stage starts out at 0. I don't need next iter state at all, right? I never call that now. So get rid of the function that was in my hot path, right? And run it, debug it. It fails now. Out of bounds. 155.
In your car,
hold on, what? Length is 0. Oh, shoot. We have to... we don't want to check it if it's out of bounds. So this would be if I is less than self.rooms.bigrooms.len and that. So then I guess it's better to actually promote that to a usize. Go back to saying as u8 there. Put that there with small rooms. Okay. Try again. Attempt to add with overflow. 138. Oh, shoot. I didn't check 255. Which means I don't really need this. Well, hold on. There's that. I should just move that into the loop. That fixes it. Alright. It's really hacky now, just trying to get it fast. Like, it's all assuming that there are a certain number of rooms total. Ooh. That killed it. That's slower now. Much slower. That was a bad move. Yeah, that regressed. Probably because it's walking a lot. Okay. Then let's undo. Just hold down that Control Z for a while. Small room set is gone. Or did I want small room set? I can't remember. I think that's where it was, right? Yeah. You only need as many IDs as there are Ks, so generate the IDs during parsing. Yeah. I'm getting tired though. And it looks like I need to undo some more. I need to undo until room set iter stage comes back. What's up? Before I added small room set. I guess so. Guess I'm undoing even more. Okay. I got it faster than 75 though, didn't I? So do I want to redo some? I'm getting tired now. I don't remember what some of these things were. Right, it contains, yep. Insert, yes, we need that. And remove. It's like the code is writing itself. Is this it? Really, I should be stashing it in Git between each time I run it. This might be where the closest I got. The fastest I got, right? Yeah. So like, what was it, 30 milliseconds? I think I'll just call it there. 21 milliseconds. I think I'm going to call it there. It's not perfect. I think Sarian's on the right track where I have I had one hash set that I have in there. If I optimize that hash set better, not have so many holes, but just have as many holes as I need rooms, then we're approaching the best we can get, right? I'm going to call it here. Let's see who else is streaming right now. Hey, let's go raid Chris. We're going to raid CM Griffing. So I'll be back either late tonight or tomorrow to do the next day, day 13, right? And if it's tomorrow, then I might do day 13, 14 together. But yeah, this is Chris Griffing. He made the chat overlay that you see above my head. And I think he's working on another project. Hey there, 99 Magpie. So thanks for watching, people. And I'll be back either late tonight or tomorrow. Enjoy Chris's stream. See ya. Bye.
But runs itself is like, there's 8 different